In this video, you will learn how to determine the degree of the polynomial or the function, the number of multiplicities, the sign of the leading coefficient, and the number of zeros given the graph of a polynomial. Now let's start identifying and defining what a leading coefficient is. Now, polynomials contain terms that are made of constants, coefficients, and variables. Let's say our polynomial or function is f of x equals ax cubed plus bx squared plus cx plus d. So the coefficients here, a, b, c, are placed in front of the variables, and our variables here are x cubed x raised to the power of 3, x raised to the power of 2, and x. And d here is a constant. Now, the leading coefficient is found with the variable that has the highest exponent. So in this case, in this given function, the variable here that has the highest exponent is this one, the first term, x cubed. Therefore, a here is the leading coefficient. Now, how do we determine the sign of the leading coefficient? So there are only two signs of the leading coefficient. It could either be positive or negative. And how to determine whether the leading coefficient is positive or negative given a graph. Now, the sign of the leading coefficient depends on the end behavior of the given graph. So, if the graph goes up to the far right, let's say that one, then that means the leading coefficient is positive. In this case, the leading coefficient is a, so a here is positive. But if the graph goes down to the far right, so if the graph at the end behavior of the graph, or the end of the graph looks like this, goes down to the far right, then the leading coefficient is negative. Now, how do we determine or identify the zeros and their multiplicities given a graph? Now, graphs behave differently at various x-intercepts. Now, the zeros are also the x-intercepts, or the solution to the equation, or to the given polynomial equation. So graphs behave differently. So for zeros with even multiplicities, the graphs touch or are tangent to the x-axis, and for zeros with odd multiplicities, the graphs cross or intersect the x-axis. Now, if the graph crosses the x-axis as 0, let's say for example, okay, the graph looks like this. That one, if the graph crosses the x-axis at a 0, then it is a 0 with odd multiplicity. But if the graph touches and bounces off the x-axis, let's say it looks like this, then it is a 0 with even multiplicity. And the higher the multiplicity of the 0, the flatter the graph gets at 0. Say for example, your graph looks like this. Okay, so this one is a 0 with multiplicity of 3. These are the three common behavior of a graph of a polynomial. So we have the single 0 when the graph crosses the x-axis, and we have 0 with multiplicity of 2 if the graph touches and bounces off the x-axis. And then we have this one, the 0 with multiplicity 3. So it doesn't directly cross the x-axis, it flattens here a bit. So you have to take note that the graph of a polynomial function will touch the x-axis at zeros with even multiplicities, and the graph will cross the x-axis at zeros with odd multiplicities. And the higher the multiplicity, the flatter the curve is at the zero. And the sum of the multiplicities that would determine the degree of the polynomial function. So let's take a look at the example here. This given graph here. First, let's determine the sign of the leading coefficient of this given graph here. Taking a look at the end behavior of the graph, the far right end, this one here, the graph goes up at far right end, so that means the leading coefficient is positive. And now let's take a look at the zeros of the graph. So the graph touches the x-axis at this point, this one, this one, and this one. 1, 2, 3, 4, 5 times. And let's analyze the behavior of the graph at each of the zeros. So let's start here. At x equals -6, the graph just crosses the x-axis. It doesn't bounce off, and it isn't flattened. So that means this is a single zero. So we can write that as, since this is x equals -6, so we can write that as x plus 6. And then the next one, this one is -3. -3, x equals -3. So the graph here crosses at x equals -3, and it doesn't bounce off, and it's not flattened. So that one is a single zero. So we can write that as x plus 3. Okay. Multiplicity is only 1. So 1, 1. And then the next one is this one. The graph here again crosses the x-axis at x equals -2. You can write that as x plus 2, single multiplicity, a single zero. And then this graph here, this part of the graph here crosses the x-axis at x equals 0. So we can write this as x plus 0 with a single multiplicity. Then the last part of the graph is this one. Okay, the graph here crosses the x-axis at x equals 4. This one is x equals 0. So we can write that as x minus 4. So this is now the equation of the function, or the polynomial function, and the graph is this. So you just have to expand this, or you can rewrite this as x plus 6 times x plus 3 times x plus 2 times x minus 4. Now if you're going to multiply all of the x's here, this would give us x to the 5th. And this is the highest exponent, and the variable with the highest exponent, and this is also determines the degree of the function. So the degree of the function is equal to 5. And the number of zeros here are also 5.